All right, the goal of this video is to walk you through how to use a laser cutter to cut a layered stack of contour lines in a topographic image. So that starts with figuring out what our topographic map is, the region of interest. You can do this a number of ways. I like to use CalTopo, it's free. So you can just navigate to caltopo.com. You'll end up with a map of the US. You can do this in Google as well. I just find this easier to generate GPS coordinates. So the first thing we need to do is find the region of interest and get the GPS coordinate that is sort of the centroid of that region of interest. So in Caltopo you can go in here, and this video I'll just walk you through how to do this for Pikes Peak. So type in Pikes Peak, bam, you've got Pikes Peak. We want to center this in our sort of topographic map. We don't need to draw boundaries yet. We'll do that in a separate browser-based program. So if you right-click on where you want the center of your map to be, you can go to Point Info and then Position and Elevation. That'll generate a variety of different coordinate system coordinates. If you look at the decimal degrees variables here, I'm going to just Control-C to copy that. And then I'm going to go to terrain STL, terrain to STL. That's this. If you just Google terrain to STL, they'll pull up this person who created this really nice, simple program that will take a topographic image and render that into an STL file that you can then 3D print. And I'll walk you through that. So this video would also serve to just 3D print a topographic area. But if we want to go all the way to laser cutting it, then we need to take that STL file, which is just a 3D volume or mesh object, and we need to slice that into discrete layers that would represent, say, the plywood or plastic that you're going to use to assemble it. So now that we have this, let's just walk you through here. You just copy and paste. So I'll grab the first coordinate, put it in the latitude coordinate, grab the second one, paste it in here, click center to view. I already had it centered, but you can see that that's right here. And then you can use the scroll to zoom in, and you'll see the red box, which is centered on the coordinates that you input here from CalTopo. So this is the same region that we are looking at here on our CalTopo map. Okay, so once you have the location centered, the box itself, or the size of your STL file in X and Y dimensions, is modified in this model details region over here on the right. So you can augment the box width. It's pretty sensitive. These are in units of degrees or decimal degrees. And you can change the box height like this. Each time you do that, it's kind of annoying. It changes where the centroid of that is, so you may have to drag your box around slightly. So it's not amazing, but you can play around with it a little bit, and you can get it set up the way you want. You can also scale the whole box, meaning you lock the aspect ratio and change both dimensions simultaneously by the same degree, which is helpful. So once you get the shape of the box correct, you can also just modify the overall size or dimensionality relative to each other. So let's say you knock that out, you get this region right here, and now the last thing to change is the vertical scaling. The vertical scaling is actually the relief in the vertical dimension of the elevation. In other words, sort of how emphasized is the sort of vertical component of your topographic map going to be when you generate this into a three-dimensional file. So the larger the vertical scaling value is here, it's set to 1, then essentially the taller the steps will be for the vertical component of your file, which means that mountains will look sharper and taller. If you flatten this out, which is the default 0.5, even something as dramatic as Pikes Peak will sort of come out really flat. So I've found that anywhere from 2 to 4 works pretty well. 4 looks pretty good. The problem with this is it's so dramatic in terms of the vertical relief that it can take many slices on the laser cutter, meaning lots of material, to actually build it up from scratch. So you may have to, this will also depend on how large in physical space in inches, x by y, you want to create your laser cut file. If it's really small, then vertical relief or vertical scaling can probably be large. If you're trying to make it like 10 by 10 inches or 12 by 12 inches, then the vertical scaling, if you have it set to 4, will probably require anywhere from 50 to 100 pieces of material individually to get it to go from the bottom of Pikes Peak to the top as a reference. So I'm going to pop over to conditions that I already set up. So this is a region that I actually already set up. Here are my model details, so I like the vertical scaling of 2 here. Water and base settings. Water drop. If you have water regions, which we do here, you can modify this, which will lower that relative to the base surface of your model. So you can sort of emphasize or dramatize water. I haven't played around with that, so you'd have to play with that a little bit. And the base height I found to not change anything at all. So I'm going to leave this set to a base height of 1, but it actually doesn't matter. And then you can go to instructions here and it gives you just quick notes. This is it. The program's super simple. So once you have your region and your model details set up, you click this button, Generate Model. It's really fast. You click it once, it's done. It doesn't do anything. Then you have to click the Download button. So you click Download. That'll prompt you to save it somewhere. So I'll just save it to my Downloads section. It's going to save it as a zip file. I'll click Save. I can pull this up and I can unzip this, and it's going to give me a file called STLs, and then inside of that will be raw model and then some numerical indicator for that file. So you'll want to drag this off onto your desktop or some other place, because right now it's archived. So you want to unarchive it, unzip it, move it to a space where it's uncompressed, and then we will open that in a separate program. Okay, next thing you want to do is open Autodesk Fusion 360, so you can get a free educational license for this for a year, or you can get a paid license. This comes from Autodesk. Just go to autodesk.com, Fusion 360, and download that if you don't already have it. And so you're going to end up, when you open it and you log in, you'll have something that looks like this. So first step we need to do is actually load our STL model that we just saved from that STL converter, that browser-based converter, into a sort of mesh framework, which is like a three-dimensional model, but really it's only representing the contours, the exterior of it, and not treating it as a full-filled three-dimensional volume, which may seem like semantics, but it's important for a couple of the steps that we need to do here. So to do this, we'll go up to Insert button here, and then Insert Mesh, and then you can navigate to where you saved your uncompressed once you've removed the zip. And so I'm going to pull this raw model up and then click Open. And so you'll end up seeing that region of our STL file, and this is Pikes Peak here. So as I mentioned before, the vertical relief here, like if you wanted these peaks to be steeper and more dramatic, you would have changed that vertical scaling function in the STL converter, and everything would have been taller and more pointy. I found that this is pretty good for practical use, but your model size may dictate differently. Notice that the way that this produces, it gives you this huge volume of sort of empty block space here, which we're going to want to remove. You don't have to if you want it to be this thick, but it's going to be a ton of material wasted. And so we've got to do a couple things first to get rid of that chunk of material. To get rid of that big block of material, you actually have to convert this mesh file, because right now you can see these are just facets that have sort of rendered the profile of the object. But there's actually nothing inside of this shape. It's just sort of the contours that have been rendered in this mesh. We need to convert this to a solid object so that the software recognizes every point within the volume, so then we can remove that and then we'll convert it back to a mesh. So we're going to convert it to what's called a brep file first. So to do that, you're going to go up here under Solid and then the Modify option, and then go all the way down to let's see here, Actually, before we do that, first thing we need to do is go up to the very top of this sort of edit tree here, which collects all of the different shapes and bodies and sketches that we have. Go up to the very top one, and this little bullet says Activate Component. Right click on that, and then go all the way to the bottom and say Do not capture design history, and then select Continue. Once you've done that, now we can go up to Modify, and then we get this Convert option, Mesh option. And Convert option. But the Mesh option, you see we have two directions. We can go Mesh to BREP or BREP to Mesh. We're going to use both. We have a Mesh now, so we need to convert that to the BREP file. So we'll select our object here. We get this sort of decision tree here. Select the object. We've got one selected. Press OK. So it will turn dark gray, which means now the software recognizes this as an object rather than a mesh. So remember, the whole point of doing this is we want to remove a big chunk of this space here. So what we need to do now is flip this thing over, and you can equivalently do this by using this orientation sort of tool up here. You can click bottom. That'll flip the bottom up for you. And now what we need to do is draw a rectangle that's slightly larger than the base, and we're going to use that rectangle to sort of cut back and up into the solid object to whatever degree we want and remove that volume from the material, and then we'll resave this as a mesh. So to do that, you go up under solid here again, and then all the way to the left you'll have a create sketch button. Press that, and nothing's going to happen except you'll have the option to select any planes that you want to draw your sketch onto. And since we're on the bottom, we want to select this bottom plane, which is coincident with the origin and the base of the model. So click that. May reorient things, it's not a big deal. Once you select that, now that's the plane in which you can sketch a two-dimensional drawing. And so up here, now you can see you've got the sketch tool highlighted and lots of options. And we want this 2-point rectangle option. And I'm going to select that, and now I've got this crosshair. And I'm just going to move sort of left and down from the origin and left click. And then you don't need to hold this. And then I'm just going to include something slightly larger than the actual base of the model. It doesn't matter exactly what it is. And then I'm going to left click again. That gives me this blue box. And then I'm going to go up here to Finish Sketch. So now I have this blue sketch that's sitting at the base of the model. Now what I want to do is take that blue rectangle and drag it vertically by whatever amount that I want in distance, and what that's going to do is sort of eat up that volume and remove it from the model. To do that, I like to use the press pull option, so I'll click that, and then it's going to ask me, it's going to give me the same sort of task pane here, where it's going to ask me to select, and I'm going to select my whole face here. You don't want to select just one of the edges, which is highlighted in blue. You want it so that you're inside the volume of that face, and you're selecting the whole face. Now the whole face is blue, and you can see now I've got this blue arrow that's pointing vertically, and what that means is I can actually physically hold this and drag this vertically to where I want, or I can over here write how large I want that to go. I've already played around with this. I know this is roughly 18 millimeters that I want to remove, and so you can see now in pink that's the entire original rectangular sketch now pulled vertically 18 millimeters from the origin, and that looks pretty good. So if you sort of zoom in here, you can see now my model, once I start to create this in the laser cutter, I may only need a couple pieces of my plywood or plastic or cardboard or whatever here, rather than like 20 of them. So you can modify this as you see fit. I'm going to select OK, and what we're left with then is sort of a truncated model of what we had before. All right, so then the next step is to convert this BREP file, the solid, which we needed to edit, back to a mesh file. The mesh is relevant for the slicer, which we're going to employ next. So in order to do this, we'll go back to the Modify tool, go all the way back down to the mesh, and now we're going BREP to mesh. And we need to select the body, so we'll select this whole body. It becomes blue as it's highlighted. You get lots of options here in terms of like how detailed of a mesh you're going to create. I like to choose a refinement option of high. You can play with these parameters to adjust exactly how much resolution and detail is articulated here. But if you leave it as default, then it's not going to gain or lose detail from what you would originally imported from the STL file. So you can go ahead and just click OK there, and now it's pink because pink is considered a mesh object. Okay, so that's our object. Now what we need to do is move this mesh object into a separate plugin slicer. So that requires you to have the slicer plugin in your Autodesk Fusion 360. If you do, this is easy. You can go to Tools and then Make and then click Slicer for Fusion 360, and this will automatically take this model into a separate attached program. If you don't have the slicer yet, let me show you where to grab that. So to find it, actually Autodesk discontinued this just recently, but in that they don't support it anymore. So if you go to the plugins on the Autodesk site and you look for the slicer, you'll find it. You click it to download, it'll give you an error. So if you just Google Fusion 360 Slicer, you'll get under knowledge.autodesk.com, you'll get this option. Click that, Slicer for Fusion 360, and what you'll get here are two options, one for Windows and one Mac, that are executable zip or archive files. So click the one that's relevant for you, download this, unzip it, install it, restart your Fusion 360 program. If you need to do that, if you have to restart all of that, then you're going to want to save this file, this mesh file, before you do that so you can reload it. So do all of that. Once you get it all squared away, you go to Make and then Slicer for Fusion 360, and I need to select the object here. So I select that, and again, refinement, I'm going to choose high and then click OK. Okay, so this is what I get. I get a model that has then been imported into my Slicer for Fusion 360, separate software program. These menus may be slightly hard to see because it doesn't support the high resolution display that I'm using, but I'll sort of walk you through what these are. It's pretty straightforward. So first thing you need to do is under the manufacturing settings, over here there's a little pencil mark. If you haven't done this already, you'll want to go to the pencil mark and actually input the type of material that you expect to use to create this laser cut topo map. I've already done that. I'll show you what I did. So I have wood. It says 1/8 inch thick, 12 by 12 inch. So these are the sheets that I buy that I'm going to use to make this model. If you don't have this already, which wasn't default here, everything else here, these are all pieces of paper, you would just add you press plus and then double click on it to edit the name, and then I just put this name in here. So then underneath, once all the settings are different depending on what the material is. So I'll choose wood 1/8 inch thick here. Make sure the units are relevant to you, whether that's millimeters or inches. I chose inches because that's the dimensionality of these wood sheets that I buy, these plywood sheets. So they're 12 inch by 12 inch shapes. The thickness of these is 0.125, which is 1/8 inch thick. The horizontal margin and the vertical margin, these are distances from the edge of the 12 inches that the tool will leave unperturbed in case, say, your laser cutter can't cut to the edge of your material. Most laser cutters can, so you can leave that at 0, but if, say, you're using a CNC router for this same sort of project, you may have to keep the tool a 1/2 inch from the edge of your template, in which case you would enter it into the margin here. The cutting tool parameters, you have the slot offset, which is another word for the kerf. So it's the width of the, the slot offset is not. The slot offset is if you choose to use the slicer to make a slotted sort of 3-dimensional structure, sort of like those like dinosaur puzzles that you cut out of a laser that fit together with orthogonal slots. This is like the tolerance. So you can add extra distance in your slots to give flexibility so they're not so tight in terms of their fit. We're not doing that because we're creating layers. Ours is not slotted and fitted together. The tool diameter is the kerf. The kerf meaning the width of whatever the object is that you're using to cut. So if you're using a CNC router, then that's the width or half the diameter of your router bit. For a laser, typically these are pretty small. I'm estimating mine at 0.005. That's a function of where you are in the focal plane and exactly what sort of optics you have. But usually these are in the sort of 0.001 millimeter range ish. But you can sort of modify this as needed, but 0.005 usually is a good start. So you click that, you click done. That just import sort of a new template for the material that you're going to use, which is crucial. You need to do that so then because it's going to generate a plan for how to cut this and how to assemble it. Then you need to go up to the drop down and actually choose that material that you just set. So I'll choose wood, 1/8 thick, 12 by 12. Okay. Next, you can adjust the overall size of your object. Note that if you right click and hold, you get the rotation option in the slicer software. So I want maybe this thing to be, I'm going to have a height of like 10 inches. And I think the height parameter here, though I'm not positive, I think the height that they're referring to is actually this dimension, the height from the bottom down here to the top here. So that is a little bit confusing, but you can modify this as needed until you get sort of the size. If you have this set to uniform scale, then all the XYZ parameters here, height, width, length, are going to change accordingly to maintain the aspect ratio, which is probably what you want. Okay, so this is where it gets interesting. So you can choose your construction technique here, which is really how this thing's going to be sliced. So you've got 6 options. The one that you're going to probably use most often is going to be stack slices. And what that's going to do is it's going to convert your object into a bunch of individual slices based on whatever the manufacturing settings that you chose. In this case, we chose that 1/8 inch thick piece of plywood. That's 12 by 12. Notice though that the default here cut these in probably the wrong dimension. I guess you could do it this way. This is kind of interesting looking. But oftentimes you're going to want to do this in a dimension where you're cutting 90 degrees to this. So your layering sort of goes with the natural elevation contours of the topo map. Here they're going the opposite. So in order to do that, I need to click this slice direction button over here. And if I click that, it gives me this option that says drag the blue handle for free rotation or click on any of the axes for constrained rotation. This is a little bit confusing, but essentially what you want to do is rotate this thing, and then this blue sort of object here, if you hover over it and you get this sort of rotate option and you click it, it's going to rotate the angle from which those slices are made relative to your object. If you are hovering and you accidentally see this sort of plus button, what that means is if you click that first, it will lock this blue rotation edit tool along whatever axis that is. And sometimes this takes a little bit of playing with to figure out exactly which direction you need to rotate this. But I think what I can do is first click this blue rotation axis. So I'm going to left click this. That locks this in just that axis, you can see. Now if I click this, what that's going to do, you can see this is rotating. That yellow plane is the plane, and then you can see over on the right, I'm trying to get to 90 degrees because that's really what I want to do, is make this thing flat, and then I'll let go. And what that should do is automatically generate my file where I have my objects now being cut in that sort of vertical dimension. So once you've finished this, you get under stack slices, you get some options here. You can choose this dowels button. That's if you're constructing something where you need some dowels to be cut and used to hold things vertically. I don't need that in this case, but if you did, you would click that and you can change the diameter of the dowels, and that means the laser will cut those holes out so you can drop dowels in to glue them up. That will hold things up vertically if you need to. Modify form. This is if you look at the very bottom here, you have some options to change this. I'd recommend doing all of your edits in Fusion 360 because it's going to be a lot easier, but this allows you to do some sort of material modifications there. Assembly steps is where it gets useful. So now we've cut this, and you can actually see the default is that it's going to construct this thing out of cardboard. So you can see the corrugate of the object. If you go all the way down to the bottom, it says cardboard, but I'm going to select plywood, and then you can see what this object's actually going to look like out of plywood. So once you have this, what you can also see then is I have this slider bar down at the bottom, which says start on the left and end on the right, with these steps that I can add or remove, and they're literally showing me every step in the assembly process here. So I can drag this, and you can see, maybe it's easier to see from this dimension, you can see all of those. So this can be really helpful in the assembly step itself. You can see there's a lot of really small objects here that you may or may not want to mess around with, up to you. But this is super handy here. And then the last button here is Get Plans. And so now what I see here, and actually you could see this the entire time, it was just over here on the far right, these objects are actually all of the cut layers that it is going to transcribe into a format for the laser cutter. So you can see here it's got 27 layers, and then the plans provide you each of the individual steps and cuts from this object. So you can go through and look at all of the pieces that you're cutting and keep them together and assemble them in the correct order. Okay, and so when you're selected on the Get Plans option here, notice at the very bottom you have the file type where you can choose from EPS, PDF, and DXF, the unit, which is in inches, and then you can do directly export to my computer. And so that's going to generate all of the relevant files that it has listed here for you to create the objects on your laser. So I chose to save my files as PDF to the computer because the Dremel Digilab 40-watt laser that we use interprets PDFs most easily. So when you do that, you can see that you get all of those shapes then directly like this. And so you can scroll as you have all these. It's possible that you'll need to sort of resave these as individual PDF files because if you try to load this entire file all at once into the Dremel software, it's going to interpret all this stuff. So it's probably best for you to actually parse this and use either an online program which allows you to parse the PDF. So like pdfcombiner.com is a useful tool. But there's a variety of ways. If you save this as an EPS type file, that's going to be directly editable in Illustrator if you need to make additional modifications to your structure. So that's something to keep in mind as well. All right. So splitting your PDF can be as easy or as hard as you make it. If you have Adobe Acrobat, you can use the extract pages function, which will just look at every single page in a PDF and pull it out as an individual file. Sometimes you can get lucky with online versions like that, like the combined PDF or the split PDF sites, though they may limit the number of extractions you can do in a single document. So another way to do this is manually. If you don't have like a million files, I like to use PDF Reader by Exodio or Shodo. And because it's sort of an alternative to Acrobat that offers editing capability and extraction capability, but it's free. So first thing to do then would just be to navigate to the combined file that you have. In this case, this is what I call Pikes Peak laser files. It's a single file, but it's just that long list of all the files. And so pull that up and you can see down here this is one of 18 pages. So what you can do from here is up here you can go to edit pages, and then that's going to display all 18 of your pages, and you can see that you have lots of options for each. So you could go through and select in the top right corner, and you could save multiple files in a single extracted document, where you go through and save them individually. So what I'll do is just select the first one, and I will just press the download button, and then I'm going to go to my Topo Projects, Pikes Peak, split PDFs, and actually I'm going to delete these files because these were attempts, and I'm just going to name this file 1, and then I'm going to go here. Oops, I need to pull this back up, edit pages, and then I can click download, and I'll call this one 2, and I'll click this one and get rid of that one, and so on until I get through my 18 files. So this is a little brute force, but it's really only going to take me about a minute.